Thank you and good morning, everyone, and thank you for the opportunity to be here and present for you today. My topic is split into two parts. The first part is the timing of preservation treatments for the work that we've completed for RTC of Washoe County with Scott Gibson. And then the second part will be the surface treatments QA construction best practices tech briefs that we are currently working on for Nevada DOT and Federal Highway Administrations. So I split it half-half between the two to be fair. So starting with the first topic, we looked into the effectiveness and the optimum timing of applications of a surface treatments. And in this case, what I'm presenting right now, it was specifically for slurry seal. Similar effort has been conducted for Cape Seal, and now we're working on a similar evaluation for microsurfacing. And those were the treatments that are used by RTC of Washoe County. So slurry seal, they have been used by the county for some time now, but there were no really guidelines on when to apply them specifically. So they were really applied at different times of the pavement life. Some of them were as early as right after construction, and there are good reasons for that, at least from a striping perspectives, funding perspectives. So they were part of the construction project, and some of them were applied as late as 9 years after pavement construction, whether that construction was total reconstruction, new pavement, or an overlay project. The question is basically to answers were, well, how effective are those pavement preservation programs? If we look at the PCI data and all of that Scott presented, it shows you that there is an impact. And can we quantify that impact? But more importantly, can we justify the cost for those pavement preservations? And then can we find the optimum timing? When would be the best time to get in, do your pavement preservations, and get the most out of that cost or investment? So the study had really two phases that are very similar. The difference between the two phases is that under phase one, we only looked into a single application of a slurry seal throughout the life of the pavement. So we went back through the good database that we had, a 15 years database, and we looked if you apply a single slurry seal throughout that pavement life, what will happen to that pavement? The phase two looked into a sequential application. So you walk in and you do a slurry seal, let's say at year 3, and then you wait 4, 5, or 6 years and you do another slurry seal applications. What's the impact of that? So I'm going to present both in parallel, the phase 1 and the phase 2 evaluations. Just quickly summarizing the slurry seal treatments, all of those treatments were applied that were evaluated in this study were applied on dense graded hot mix asphalt. Typically, they are 1/2 inch or 3/4 of an inch nominal maximum aggregate size. The slurry seals applications followed the ISSA publications. Most of them were latex modified, cationic, quickset emulsions, and then the majority of the applications were between the period of June and September. So looking into so we collected all that database for 15 years, which has new construction versus overlay pavement. They received the treatment, and also we looked into it by traffic category, like arterial, correctors, industrials, and local streets. And we had different pavement sections within each group. And then we looked at the performance of those pavement sections, and we started developing performance models or performance curves. And here's an example of the actual data, the average performance curve. So if you look at the green line, this is basically on average, the performance of the pavements that didn't see any surface treatment throughout their pavement lives. So you can see they start with a high PCI, and within a year of 14, they reach a PCI of 40, which is your trigger, if you want, for reconstruction. Now, if you look at the red line, this is basically when you apply a single application of slurry seal at year 3 versus the blue line if you apply a single application of slurry seal at year 7. So in the database for the single application of slurry seals, we had pavement that they've received slurry seal at year 0, which means right after construction, at year 1, 3, 5, 7, and 9. That's how we group the data. So this is what we observed in the field, in the database. It's not something that we recommend. It's something the practice been, it spreads over those different years. if you look very carefully on those two plots, this is actually one of the good examples. So we identified, two parameters that we looked into it. One is what we call the performance life, which is eventually how long it will take you to reach the pre-treatment condition. So in the case of these examples over here, it's 2 years when it's applied at year 3 versus 3 years when it's applied at year 7. But then also, more importantly, we looked at the extension in the pavement service life. So are we pushing that curve out when you reach the trigger values? If you look at the red curves, in this case, this is, like I said, one of the good examples where we get 2 years extension in the pavement life. But when you do it later on in your pavement life, even though you provide a better ride quality because your PCI is higher, but at the end of the road, more or less, you're going to need that major rehab or reconstruction almost at the same time. And that was consistently the observation from the phase 1 study. Now, if I look at on the other hand, on 2 applications of the slurry seal, and this is one of the example again of the data analyzed, you look now at your red line is the do-nothing curve, but then you come in at year 3, you do a slurry seal, and then at year 7, which means there's 4 years between the 2 applications, you do another slurry seal. And now we start clearly see that we start pushing that curve out. We start pushing that major rehab, in this case, about 3.5 years. So instead of being due around year 12.5 or 13, now it's not due till year 16 or 16.5. So you'd clearly start seeing the benefits of the surface treatment when you're applying multiple applications of that surface treatments. Now, this is all good, right? But in a summary, we find out that if you do a single application, your performance life of the treatment was anywhere between 2 to 4 years. Remember, this is the time to reach the pre-treatment condition, right? And then, except really in very few cases, the pavement service life was not extended. Though, keep in mind that we are increasing the ride quality. But we didn't push the life of the pavement. Now, when we did the sequential applications, then we found the blue one are the performance life, which are very well consistent with the phase 1 study. But if you look more importantly at the red ones, which are the extension in the pavement life, they range anywhere between about half a year all the way up to 3.6 years. So by just looking at that data, it tells you, well, maybe there's an optimum window when I should apply my surface treatments. So it works, but it works if I do it at the right time, right? So the question was, the next step is, well, how can we find that optimum windows? And this is where you do a benefit-cost analysis. In a case of a single application of slurry seal, we look at the area below the slurry seal and above your do-nothing curve, and we compare that to the area under the do-nothing curve, and then with the cost dollars, we bring them back with the present value, worth values, to the time 0, with a given discount rate, and then we calculate the benefit cost ratio for every application. So remember, every application was at different timing throughout the pavement life. The same thing we do it when you have a sequential applications, but now your area eventually should be larger because you have 2 applications of your slurry seal treatments. And then basically, we look at the results, and this is the single application of the slurry seal. On the left-hand side are for new construction pavements. On the right-hand side are for overlay pavements. And the 3 different curves are for the 3 different road categories within each group. The higher the benefit cost is what you're looking for, right? A higher benefit with a minimal cost. That's why we're looking for a higher ratio. You clearly see on both sides there's a peak, right? Around year 3 is the most highest peak. In the case of the overlay, it's anywhere between year 3 and year 5. So it's telling you that, according to this, if you wait, right, few years, in this case, we're saying 3 to 5 years, and you do your first slurry seal treatments, you're going to get the most benefit out of it, okay? And that kind of makes a little bit of sense. Let the pavement age a little bit, gain some strength, because it's going to help you with the early rutting, early permanent deformations, but then come in early enough while the pavement is still in good condition and apply your surface treatment to kind of retard or slow down, if you want, oxidation. Because oxidation will start hurting you in terms of fatigue cracking and thermal cracking and so on. Try to slow down that effect. And the data, actually, the database is a database of 15 years. It just proved that concept very clearly. Now, when you do a sequential applications, actually it was very consistent where we find out that the first application, whether it's an overlay or a new construction, should be around year 3 to year 5. But then you follow up after about 4 years or 6 years, 4 to 6 years, when you follow up with your second application. So there is also a timing for when you do the first application and when you do your second application. And this is all on a preventive maintenance aspect. We're not talking about the corrective maintenance, right? That's what happened. When you apply it late at year 9, eventually you're doing more like a corrective maintenance. And this is where your benefit cost goes down. So based on that, we took all that information and we converted it into really a PCI value rather than the years, because it would be more convenient from the implementation perspective is to find out when is the right time to target surface treatments. For the new AC overlays, it's anywhere between a PCI of 87 and 90 when you apply your first slurry seal. Then you wait until it reaches around a PCI of 86. This is your trigger value for your second slurry seal. On the AC overlays, you get a similar ranges, but a little bit lower, okay, when you need to do all those information. And if you look at your PCI rating, right, if you compare those PCI values to your PCI rating, you'll find really you need to apply your preventive maintenance when you are in excellent to very good condition to get the most benefit cost or the most benefit out of that applications. So that's what RTC of Washoe County and they started implementing on their networks and using those threshold values to identify those pavements. We're working also with Carson City County, Douglas County to also implement a similar program when it comes to pavement preservation. So that will conclude the first part of my presentation. The second part, which is the chip seal, slurry seal, microsurfacing, and thin lift.
So the first question I have is in regarding to the measuring the performance to compare it to the baseline, if you will. What was your performance measurements that compared these applications to precondition? The second part of my question is on the sequential application, the initial at year 7 when you applied the second slurry seal. Looked like that you have extended the life of the pavement by 3 years. But as the time went by, it looked like the extension of life extended to 3.5 years. What would be contributing to extending the life from the initial stage as the time goes by?
So for the first part, we looked at the PCI and individual distresses. So we looked at the overall PCI, and the recommendations were in terms of the overall PCI, because from the implementation perspective, it's easier. But we also looked at the individual distresses to see what bringing those PCIs down, if that answers your question.
Yes.
The second part of the question is, you're referring, I believe, to this plot, right?
Exactly.
Right. So
yes.
the performance life is just how long it will take to reach the pavement condition before. Right? So as you can see in this case, for example, it was 4 years to 3 years for the first and the second. But on overall, right, it pushed it out 3.5 years. With the first application of the slurry seal, you don't get that push, right? It's good, but it's not good enough to give you the push. It's good to give you a good right quality if you want. But by following up with the second slurry seal, then on average, you get that push of about 3.5 years. And this is mainly due to slowing down the oxidation rates, because oxidations will impact the thermal cracking issues or any fatigue cracking issues. In the early life of the pavements, rutting is more critical, right? And then if you let it a little bit just gain enough strength and stiffness, and that's what you should do. Let it do that to gain enough strength, but then come in at the right time and start slowing down that rate.
Now, what do you define as the benefit cost ratio there? Yeah, the B over B0, what are you defining as benefit costs there?
So the benefit for us, the benefit cost ratio is the ratio between B to the cost. Now we have a relative benefit calculation, which is B to B naught.
So B is the benefit.
Is the benefit.
And B naught, do you have a ratio of
We
B
have.
and B
Yeah, I didn't
naught
present
there?
it here. We call it relative benefit.
Okay, okay.
B to B naught
Okay.
as well. So we looked at that as well.
And then one other question, you said that the ride was improved. What did you use to measure the ride?
The overall, we didn't measure the ride, but when you improve the PCI, right, your ride quality should eventually be.
Okay, it should
so-
improve, yeah.
Yes,
Okay,
but we
you
didn't have measurements for the ride.
Okay.
But I don't want to give the message that doing one treatment is not pushing the life. I shouldn't do it.
Okay,
There's a benefit to the public. Eventually.
okay, thank you.
If you're using benefit cost ratio, to me that implies that the cost is also changing as a function of condition, right?
Cost is changing. No, we didn't change the cost as a function of the condition. It was the cost of the treatment.
Right, but if the cost of the treatment is constant, then you're really doing a benefit analysis, not a benefit cost analysis, because cost is a constant.
Well, we looked at the bids, and then fairly enough, the costs were constant. The cost of the slurry seal throughout the life, the one that we evaluated, were fairly constant. So we went back and we used an average value, but you used the discount rate to bring it back to time zero. So
Okay, so it's a discount then.
yes. So depending when you apply it, the cost eventually will be different.
Okay.
So let's move on to the next one. So this is basically to develop, just to make sure, a quality assurance construction best practices for all those 4 different treatments that you see here on the slides. And as I said, this is a mutual effort support from FHWA and Nevada Department of Transportation. And then basically on the team, there's our program, the Pavement Engineering and Science program, and also we have NCAT as a subcontract to this project, Mike Heisman and NAMTRAM, they're working with us on this. And also we have Dean Weitzel as a consultant also working with us on this project. We do also have a national experts panel that is part of this effort. We had a meeting about a year ago in Reno, Nevada. It was a very productive all-day meeting, and the panel consisted of state public agencies, FHWA, academia, even local agencies, and then industry, just to guide us, give us feedback, read the material that we develop, provide feedbacks, adjust, and then help us also to reach out to the various agencies. What are the overall objectives of this project? Basically, we need to identify the factors that will lead to a best practices construction QA program. Okay, the existing best practices. Okay, there's a lot of documentations, there are a lot of publications right now that tell you this is how you need to do it. But the purpose of this project is to see what agencies are doing it and it's working. And then basically document, collect that information and document that information, trying to avoid what we call early failures, right? Within those, even after construction or within the first couple of years, try to avoid that problems. What agencies are doing, and they're not getting that early performance. We're not looking into to see every agency's what's the performance life of their treatment. That's not the purpose of this, the effort. And eventually, out of that work, tech briefs will be developed for each one of those treatments that will include some case studies and example specifications that basically the agencies can refer to. And if they need more details, they can go to the main report where it has a lot more details. The project has 3 tasks. First was to put together the expert panels and select the factors that will contribute to good performing, good practice, quality assurance construction practices, and conduct some state surveys. The second one is to collect the necessary data to be able to write the tech briefs, and eventually task 3 is to develop the materials, the report, and the tech briefs. So we had this is where we are right now at task 3 really. We're wrapping up the reports. We're getting ready to send it out to the panels for review and comments, and then meanwhile we'll be working on extracting the information into the tech briefs. So based on the meetings that we had in Reno, we ended up with really 2 tier surveys. The tier 1 survey was short, 5 questions, up to the point, and then basically it looked into some general questions trying to identify out of the respondents which are the agencies and the contractors that we want to move forward for the Tier 2 survey. Okay? So I would like here to acknowledge, the AASHTO subcommittee on construction, on maintenance, ISSA, LTAP, TTAP, NAPA. All these entities helped us to disseminate the survey. And because of that, we get 182 responses. So bottom line, lesson learned, keep it short, no more than 5 questions, you get good feedbacks. 124 owner agencies responded between state and local, and 58 contractors responded. We took all that data and then we analyzed it, and we screened it to come up with the 11 agencies that we thought that we need to follow more thoroughly with them. And then the second phase was really phone interviews. It wasn't really like a survey. And to do that, we developed, materials for us. So, because remember, we have 2 entities on the team. There's UNR and NCAT. So we wanted, at a minimum, both to collect the same information, right? There's a minimum information that we wanted. So we documented what we want to look for, what we want to ask the agencies for, such as, what kind of standard construction specifications, construction QA programs, and so on. For example, what aspects you think it's related to proper or improper construction practices. We wanted to get a feedback. And most important, there's always the last question at the end. If we want to follow through with case studies, are you willing to provide data, whatever? So that also was sometimes, it helped in the selection, if you want, right? If somebody said, nope, this is where I want to stop, that it's kind of like the end of the line for us, right? Very good. These are some of the examples, We took that data. There are, the responses, when we did the phone interviews, there are specific questions where we have kind of a preset answers, if you want, that you can summarize, but there are also responses where there are more specifics. But just to give you a flavor, this is what are the key aspects of construction resulting in good experiences, in your opinion. And then you look here at the different responses. They say, equipment calibration, pavement certificate, personnel certification, verification of materials, application rates, and so on. If you look at the different treatments, for example, in the chip seals, we see that the equipment calibrations comes up. You have the verification of materials and application rates that 7 out of the interview ones was more critical, and so on. So it gives you a little bit of flavor what the agency think it's critical for those applications. Another example is what are the areas of quality assurance needing improvements. And then, believe it or not, the majority across was mainly training. Okay? Another aspect is the primary causes of early distresses. And we defined in that document very clearly what we mean we came up with the definitions so we can make sure across we're talking the same language, right? What's a slurry seal? What's a chip seal? What's a microsurfacing? And what's a thin lift asphalt overlay? And by the way here, what we mean by thin lift asphalt overlay, less than 1 inch. We also defined, for example, what do we mean by early distresses? Are you getting those early failures, like chip loss? Are you getting any bleeding problem right away? These guys are raveling issues, and so on. And again, here, if you look at it, it seems like materials and mixed design issues were high, for example. Climate, temperatures, where do you apply it? Seems to be also, a critical issues. So we have several of these, and then we came up with a ranking system so that we can rank all those different agencies, rely on a contractor's feedback sometimes to close the loop. If there's something missing from the agency, we can look at the contractors that work for those agencies and try to basically understand what's happening. We came up and identified what we call lead agencies. The lead agencies are the ones that we're going to follow through and then collect even further information in terms of specification, case studies, and so on. We ended up with several. We reach out to those lead agencies, and I'm going to give you a summary of who are those lead agencies under each surface treatments. And then we had a contact person where we had follow-up discussions, collecting materials, and so on. And they helped us a lot in that process to point us clearly where to find the information. Because from one agency to another, you'll find that sometimes the information can go under the construction specs, but in some other agencies it could be under the maintenance specs or it could be under material specs. So you need someone really that's knowledgeable from the agency to point you out to all of these different information needed. This is the spread, and these are the agencies. We had for example, for chip seal, California, Minnesota, Spokane County, from Seattle, Texas, slurry seal, California, City of Columbus, Ohio. They had a good program from slurry seal, Virginia, microsurfacing, again, California, Minnesota, and Virginia, and thin lift asphalt overlay. We had California, Florida, Michigan, and Ohio. So these are the agencies that we are targeting under each one of those surface treatments. Some of them might come, under multiple of those treatments, like in California, Minnesota, and so on. And then you can see what we tried also to take into consideration the spread throughout the United States, to be able to capture the different climatic effects. This is the summary. I know it's very hard to probably to read, but this is the summary of the main report sections, where there will be an introduction, there will be a section summarizing all the surveys and the outcome from the survey and so on. But then there is also, and how we selected the lead agencies, what led to the selection of those lead agencies. But then chapter 4 is mainly the summary of for every treatment, we had 3 sections: the materials and testing specifications, the construction specifications, practices, and then the quality assurance specifications. So you're going to find for chip seal, slurry seal, microsurfacing, and thin lift asphalt overlay, those 3 major sections that describes for all those lead agencies that fits under that surface treatments, what they have been doing and then how they've been doing it. And then at the end, chapter 5 comes in as a case study. The case study were basically now for those lead agencies that we were able to get actual projects, document those projects. And then we had the opportunity to visit 2 of these 2 projects. One is in California on ES 395, and the other one actually in Spokane. One was a chip seal project, the other one was a slurry seal project. So we documented those, the good practices, and then those will be summarized under chapter 5. And of course, there is at the end a summary and a comparison across all those different specifications. There are a lot of common aspects that we observed that might be worthwhile to highlight those, okay, that are leading to good practices, good quality assurance construction practices. So this is in a summary, really, what we're doing. As I said, we're drafting out the report. We're going to send it out to the panels for review. And then in the meanwhile, we'll be working on the tech briefs.
One more question, Elie, going back to the initial part of the presentation. Mm-hmm. How did you define the control performance curve?
From the actual database.
Okay, so were there adjacent sections to the treated?
No, this is throughout the entire area.
Yeah.
But we looked at the pavement that have not received any treatment for the past 15 years.
Okay.
And those we developed the performance curve. What I showed you here is one, but there's really a series of curves based on the traffic level,
okay,
based on the new construction. So every phase probably has like 15 or 20 performance curves.
Okay. For
so
each
they were,
family.
yes, they were statistic. We looked at them statistically if we can group them. So we started first by those different groups, and then based on the statistics and the data available, we start grouping them, and they turn out at the end that you need to keep new construction and overlay separate, and within each one of them you have to handle it by traffic level. Okay. So those were the final groups. So every time you see do nothing, it's based on actual data.
Yes, this is going back to your earlier talk. What was the optimum time for the second slurry seal?
That's, in terms of years, it's
yes,
basically after 4 to 6 years
4 to 6
from the first one. In terms of PCI, which I like it more, why? Because most likely you can take this and implement it in your agency better, because the climate is different and the material is different. So it might take you maybe for the first slurry seal 5 years to reach 90, whereas maybe in Washoe County it only takes 3 years because the environment is different. Or if I take that data down to Vegas, which is totally a different harsh environment, so maybe in 2 years I will reach a 90 and I need to do the PCI. So if you want to take something out of this, I would probably take more the PCI values and try to compare them. When do you reach those values on your roadways rather than the number of years? All right, thank you.
The preceding video was produced by the National Center for Pavement Preservation. More information can be found at tsp2.org. That's tsp2.org. Additional support provided by Michigan State University.